Mass spectrometry is used to identify the contents of a sample and the quantities of those substances within that sample. This is based on a substance's weight or mass. A mass spectrometer is essentially a set of very accurate weighing scales. How it all works. Firstly, we take a blood or tissue sample, and the mass spectrometer then works in two stages. In the first stage, the sample is passed through the instrument where the masses of its individual components are measured by their time of flight. Effectively, all the components start off from the same place and are pushed through a tube towards a detector. The time it takes them to travel is related to their mass, so small things go quickly and larger things go slower. An average molecule will travel at about 50 kilometers per second. That's 1/6 of the speed of light. As each component hits the detector, the time it took to get there is recorded, and the mass of each component is revealed. The more of a particular component there is in the sample, the more hits on the detector we will get at that time. This is then shown as a mass spectrum. Time of flight is converted to a mass, or mass-to-charge ratio, and is shown along the bottom, and the height of each peak represents the amount of that component in the sample. By comparing the height of each peak between many healthy people and patients, we can find which peaks are higher or lower in the two groups. This allows us to find substances which are different and which can be used as biomarkers or targets for new medicines. One further challenge, however, is that many things can have a similar weight. From this initial process, we don't know for definite the identity of our biomarker, so we begin the second stage of analysis. This time, the mass spectrometer isolates the specific component of interest by filtering out all other components that are not of the correct weight. Our pure compound then collides with a gas, commonly nitrogen, where it is broken down into smaller fragments. We can now measure the masses of these fragments using time of flight as before. This gives us a distinct pattern of fragments, like a molecular signature, which is used to discover the identity of the compound. In reality, these two stages are often done at the same time, with modern instruments capable of generating results in just seconds, allowing us to identify and quantify thousands of components from the samples in a single analysis.